In the past, we have added functions, subtracted functions, multiplied them, and divided them. Now we are going to look at composite functions. What's it look like to compose a function with another function? What does that even mean? So, the composition of f and g, or f composed with g of x, is f of g of x. So, we apply g first, and then we apply f. So notice that the domain, which we will discuss more, is the set of all x's where x is in the domain of g, and then that output has to be in the domain of f. So if we have an x value, and we put that in to g, we will get out g of x. Then that will become the input of f. And so whenever we apply f to that, we get out f of g of x. What the composite function does is it says, I'm just going to call this two-step machine f composed with g. So let's take a look at an example. So here we have f of x equals 3x squared minus 5, and g of x equals 4x plus 1. So we want to find f of g of 2. So if we look at what that means, this is the same thing as f of g of 2. So let's find out what g of 2 is. G of 2 will equal, I'm going to put 2 in here, and so that means that 2 will go in here. So we have 4 times 2, then add 1. So this will be 9. So g of 2 can be replaced with 9. Now we find f of 9. That means that everywhere we see x, we're going to put in 9 into the function f. So f of 9 will be 3 times our 9 squared minus 5. So that will be 3 times 81 minus 5. So that will yield 243 minus 5, which is 238. Now let's look at g composed with f of 2. So this means that we are looking at g of f of 2. So this means that f is getting applied first. So let's find f of 2. So f of 2 will be 3 times the square of 2 minus 5. So that's 3 times 4 minus 5. And that should give us 7. Now let's put in, for f of 2 then, 7. That f of 2 yielded 7, and now we can find g of 7. So g says take 4 times that input and add 1, but our input was 7. So this yields for us 28 plus 1, which is 29. So now we can actually compose a function with itself. So we're looking at f composed with f of negative 1, and we'll follow the same steps as before. We'll look first at the inside and look at f of negative 1. To find f of negative 1, we will substitute negative 1 in for x. So we have 3 times the square of negative 1 minus 5. So that's 3 times positive 1 minus 5. And so that will yield for us negative 2. So f of negative 2 will be what we're going to find next. So f of negative 2 is 3 times that input squared minus 5. So this is 3 times 4 minus 5, which is 12 minus 5, which is 7. Now this time, you'll notice that we're going to keep our input as x. So our output is going to be a function. So we have f of g of x. But we're going to find g of x first. So we're going to have f of, now g applied to x is 3x minus 5. So all of this g of x is getting replaced with 3x minus 5. Now what does f say to do? F says to take that input, square it, minus 5 times that input, and then add 1. So I'm getting that from right here. X squared minus 5x plus 1, where x is the input. But our input is now 3x minus 5. So we're going to take and replace x with 3x minus 5. Now, 3x minus 5 quantity squared, we can use FOIL, or we can square the binomial. So we have 9x squared minus 30x plus 25, and that is this portion. And then we'll distribute the negative 5, so we get negative 15x plus 25, and then add 1. Collecting like terms, we have 9x squared minus 45x plus 51. Now let's look at what we obtain if we find g composed with f of x. So this means we have g of f of x. So we will replace f of x with our x squared minus 5x plus 1. So f of x is getting replaced with what we know f of x to be. Now, what does g say to do to our input? G says to take 3 times our input and subtract 5. So we'll take 3 times our input, subtract 5. And our input is x squared minus 5x plus 1. So distributing, we get 3x squared minus 15x plus 3, and then we subtract 5. So we have 3x squared minus 15x minus 2. Now, let's look at f composed with f of 2. I'm going to do this problem 2 different ways. So we've already seen that if we have f composed with f of 2, what we can do is find f of 2. And f of 2, we know is 2 squared minus 5 times 2 plus 1. So we get 4 minus 10 plus 1, and so that's negative 6 plus 1, so negative 5. So this would be f of negative 5, which we can then substitute into our function. So we'll square minus 5 times that input, and then add 1. So this will be 25 plus 25 plus 1, so it yields 51. So what's the alternative? We could find f composed with f of x, and that'd be f of x, and so we would obtain f of x squared minus 5x plus 1, which says that I need to take that input, square it, minus 5 times that input, and then add 1. So now squaring this x squared minus 5x plus 1, I'll write that out. I won't do that in my head. X squared minus 5x plus 1 times x squared minus 5x plus 1. And now we can distribute. We'd have minus 5x squared plus 25x minus 5 plus 1. Now, what is this x squared minus 5x plus 1 times itself going to be? Well, let's take x squared times each one of these. We'll get x to the fourth minus 5x cubed plus x squared. Now, let's take negative 5x times each one of these three. And then let's take 1 times each one of those three. So if I take x squared minus 5x plus 1, I get all of this. Now, we have negative 5x squared plus 25x minus 5 plus 1. That's minus 5x squared plus 25x. And then we can go ahead and take negative 5 plus 1 and get minus 4. Collecting like terms, what do we obtain? We have x to the fourth minus 10x cubed. We have the negative 5x cubed and the negative 5x cubed. Now what about x squared? We have positive x squared. So now we have 26x squared, 27x squared. So we have the minus 5. So that's going to be plus 22x squared. And now our x's. We have negative 5x, negative 5x, and positive 25x. So that's going to be positive 15x. And then what's our constant going to be? We have positive 1 and negative 4, so we get minus 3. So now, how does this help us? We want to find f of 2. Well, we've just found f of x. So what we can do is we can substitute 2 in. So f composed with f of 2 will equal 2 to the fourth minus 10 times 2 cubed plus 22 times 2 squared plus 15 times 2 minus 3. So we get 2 to the fourth is 16 minus 10 times 2 cubed will be minus 80 plus 22 times 4 will be 88. Then 15 times 2 would be 30. Subtract 3, which ends up being 51. Now, I cannot imagine you choosing to do the second method. I just wanted to show you that it would work. So let's find f of g of 5 based upon the graphs. So let's go ahead and write down what f of g of 5 means. This is f of g of 5. So let's first focus on g of 5. This means that we are going to take 5 and we are going to put it into g. So if we find 5 on our x-axis, there's x equals 5. Now where do we find the output of g? So we're going to take 5 and put it into g. So we're going to go to the curve that defines g, and we're going to go over to our y-axis. So this tells us that g of 5 is 2. So we're going to find now f of 2. And that means that we're going to now look on our x-axis for 2. And we're going to substitute that in. And this time we're going to go to our function for f. So f of 2 will be found by using, in this case, the red curve. So we'll go to the red curve, and the output will be 2. So f of 2 is 2. Now we will do the same thing. We're going to look at g of f of 1. So my suggestion is to pause the video and try this one for yourself. So now, if we find 1 on the x-axis, that's our input, and then find it on the output of f. So if we put 1 into f, we're going to get out -1. So this means now we find g of -1. And so we'll find -1 on our x-axis and substitute that in to g. And so we obtain 2. So now let's look at part C. We're going to find f. So f composed with f of 3. That will be f of 3. So we focus on the inner, so we look at f applied to 3. And so for that, we're going to find f of 3 is 1. So we need to find f of 1. So f of 1, I will put 1 into our x value and see what the output is of f, and we get -1.